Okay, welcome to the third installment of my presentation. I've actually had the hardest time trying to explain this one. This is like my 12th time trying to explain it. Hopefully I'll nail it this time. We're going to talk about passing by value, and we're going to talk about functions. Okay, so first things first, we talked about the stack and how do variables come in and out of scope. Okay, the stack is a receptacle. It's visually, we're going to represent it visually as a box, and programs and functions get stacked up onto it just like cafeteria plates. This is the side view. Cafeteria plate, second cafeteria plate, and so on and so on. To a viewer, it's important to represent this way because to a viewer, you can only see the topmost plate unless you have X-ray vision, and you can then see the bottom. That would kind of be what a pointer does, but we'll talk about this later. So to a viewer, you can only see the top one. In order to see anything that's at the bottom, the top plate has to go away, right? So this is exactly what happens when you turn on your computer and programs and functions end up getting stacked up. Now, I'm saying program and functions is pretty much the same thing. A program is just a very complicated function. A function just does one thing. A program is just a series of functions. Like Internet Explorer is a bunch of functions. I'm sure you know that. Okay, so you turn on your computer and the first thing that gets pushed, we say, oh yeah, the terms are pushed and popped. First thing that gets pushed onto the stack is your operating system. Pushed when it's on and popped when it's off. After that, I turn on my Visual Studio, right? And Visual Studio gets pushed onto the stack, right? And now the computer actually cannot see Solitaire from here. It can only see Visual Studio. At this present moment, Paint is actually on the stack right now. Okay, now I'm in Visual Studio, and the program's going to start executing. It's going to, the compiler is going to start reading line after line and line after line, blah blah blah, and it's going to get to main. And main is a function that just came to life, and so main gets pushed onto the stack. And then when function gets pushed, and so on and so on, you get it, and then you're done with main, and you finish your program, and it gets popped out, and so on and so forth. Now, let's explain how we're going to make a function. A function that's going to just add 10 to a number that's been passed to it. So imagine we're in main and we have a number. I put this number in function and it'll return the number plus 10. Very simple. So we have my function block, I have my function definition, and I have a function prototype. All the prototype does is just a warning to the compiler to say, hey, when you are in main and you're reading line after line and you get to a word that you don't understand called func, don't worry, I have a definition for it later. So either you warn the compiler by writing a prototype above main, or you can just take your entire definition and put it above main. This way, the compiler will read line after line and it'll get to functions like, oh, this is a function and this is what it does. Great, when I find it later in main, I know where to come back to. Okay, that having been said, let's see visually what happens when we're going to make an integer and a result. We're going to put a number in this integer. We're going to put this integer into a function. The function is going to get called, it's going to add 10 to that number, it's going to return a result. Right? Fair enough. So, int x, what happens? So, okay, so we're back here, we're reading. The compiler gets to void main, and as soon as it opens the first bracket, main is now pushed onto the stack. And that's all it can see. It can only see the stuff that's in here. Great. Int x. Like I explained before, it's going to look for a free memory cell, label it x, let's use red. Label it x. Next line, it's an integer, result. Okay, so I need another cell that's going to be labeled result. Right? Blah, 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 blah. Well, you get it. I can't type with this. And then we're going to initialize x to be, let's say, 79, right? Sorry, okay, so now x gets 79. What happens to the computer? It's going to find the cell labeled x, this one, and put 79 inside of it. Right? Now we're going to call the function, pass x as an argument, right? And we're going to initialize the result with the return of the function. Now, this line is really interesting. Regardless of the program, let me do a new, oh, I kind of need this. Regardless of the program, it's like the third time I say that. This, when this function returns a value, the compiler literally gets to this point of text, takes everything, deletes it, and replace it with the value that it found. That is all it is. So in this case, oh, I can only undo once, okay. In this case, result gets func x. Once the compiler jumps to func and works out the insides and gets to this point and returns this value, the compiler goes back to this point and literally replaces func open parentheses x close parentheses with the result. In this case, 79 plus 10 will be 89. This will return 89 and literally do this. And now result gets 89, so it's going to put 89 in result. So that's how a return works. Okay, that having been said, so we are here, we are at x, gets 79, so it finds the cell labeled x, puts 79 in it. The cell labeled result will get func x in it, inside here. So I need to evaluate what func x is to know what to put in here, right? So it's going to jump directly from here, from this line. It's going to jump, actually it's going to jump right in before function, before it reads function. Or it reads function and goes back, I think. I'm not sure on the detail. Jump to here, matches this argument with this parameter, right? And what happens? As soon as it's on this side of function, function is now pushed onto the stack. Okay? This way. Now anything that's living in function will be in here and will not be seen by main, just like we can see through the plate. One very important thing that you need to know is, how does this transfer happen? It's a pass by value. This is what we mean by pass by value. The value of x here is going to be passed into this value of num. They're two different integers. They're two different places in memory. What you need to do as soon as you find functions and function calls, function headers and function calls, this is a simple trick I've been using myself. I don't think it's legit to any programmer really, because I kind of use math to do this. Okay, so this is how I do it. Please bear with me, it's going to be very important later. You take the function and the parameter, and then you take this function call the way it's written, and you put a assignment sign in between. Mathematically, I just cancel out the two func, and you're left with int num gets x. Isn't that clever? Now we know that x is 79 right here, right? So now int num gets 79, and this is what's happening where? On the function, right here. It's reading function int num, and it's going to find a free space and call it num. What does it put in num? Well, this is what it puts in num. It puts 79 in num. It puts the value of x in num. This value gets copied into here. You see, it's literally been copied by using this way. Now you can see, like, for one number, copying one number is totally okay and it's fine. But once you have, I do a lot of 3D graphics, and each vertex in 3D graphics have an X, Y, and Z. Now if you have thousands of them, you don't want to have functions that pass thousands of numbers back and forth. It really makes the process really, really slow. This is why we're going to do pass by reference later. I'm just going to go on with this, and then you're going to see why passing by reference is so much cleaner. In this case, the number 79 exists in two different spots in memory. It exists at cell address 502 and at cell address 237. Obviously, we can only see this one at the moment because we're at the top of the stack. 79. Okay. Next, what does it do? Int y. Great. So there's an integer y. I'm going to label this cell y right here. Y gets number plus 10. Okay, so number was 79, so it'll replace this num literally with 79, plus 10, that's 89, and now 89 goes into cell y. I'm going to find cell labeled y and put 89 in here. Great, awesome. Then it's going to return y, and what did I say about returning y? Think of it, return y is just replacing all of this with the value of y. Think of it as a basketball player shooting a fadeaway shot. That's how I picture it in my mind. Ready? As we're here and we're returning out, right here, this is getting popped off. And like a basketball player moving backwards, shooting this into result 89. 1 second, I'm getting a phone call. I'm at work. Let me pause this. Okay, false alarm, I'm back. Okay, and where was I? Just like a function, I'm back. So we were at fading away and passing the return. So as I said, as it's being two things happen at the same time, the function gets popped off, and the return, the value of y is injected is like seriously like a fadeaway shot thrown into here, 89. Now this is gone. It's out of the scope. Num and y do not exist anymore. They're out of the picture. What exists, okay, and we're here. This is literally being replaced by 89, like this way. And now we're back here, and we have result as a cell that contains 89, and x is a cell that contains 79. And this is how functions work, really. And later on, I'll go into the fourth installment, and we're going to talk about passing by reference, and it's a lot cooler. Anyways, all right.